Have you ever wondered what forces churn beneath our feet to create the fiery spectacle of a volcano? A world of mystery and intrigue lies beneath the surface of our planet. This world is made up of several layers: the crust, the mantle, and the core. The crust, our solid and stable surface, is not one piece but a jigsaw puzzle of giant slabs called tectonic plates. These plates float on the semi-fluid mantle below. Now imagine these plates as colossal rafts, ceaselessly moving, albeit at a glacial pace. Sometimes they collide, sometimes they move apart. It's this movement that lays the foundation for a volcano's birth. When plates collide, one is often forced down into the hot mantle, melting into magma. When plates separate, magma rises to fill the gap. In both cases, the magma seeks a path upwards, setting the stage for a volcanic eruption. So it all starts with the shifting and sliding of tectonic plates deep within the Earth. Now imagine these tectonic plates moving, colliding, or pulling apart. What happens next? Well, it's a bit like a dance, a slow, powerful dance deep within the Earth. When these plates move, they create gaps or pressure points. These movements can cause the solid rock of the mantle to melt, creating what we know as magma. This magma, being less dense than the surrounding rock, naturally desires to rise, much like how a cork bobs up when submerged in water. It ascends through the cracks and weak spots in the Earth's crust, like an eager child climbing a tree. And as it rises, it collects in a magma chamber, a sort of waiting room for the magma before it makes its big debut on the Earth's surface. When the pressure in this chamber becomes too much, the magma breaks through the crust, erupting onto the surface, and thus, a volcano is born. It's quite the dramatic entrance, wouldn't you say? But not all volcanoes are born the same way. Some form at convergent boundaries where one tectonic plate is forced under another in a process called subduction. This creates intense heat and pressure, melting the crust into magma. The well-known Ring of Fire in the Pacific Ocean is a prime example of this type of volcano formation. Others form at divergent boundaries where tectonic plates are moving apart. This happens often under the ocean, creating undersea mountain ranges like the Mid-Atlantic Ridge. Here, magma rises to fill the gap, forming new crust and occasionally new volcanoes. And then there are hotspots, areas where magma rises from deep within the mantle, independent of plate boundaries. The Hawaiian Islands are a beautiful example of hotspot volcanoes. And voila, we have a volcano! But it's not as simple as it sounds. Because each volcano, like a snowflake, is unique, shaped by the specific circumstances of its birth and life. And understanding these fiery marvels helps us better understand the powerful forces at work beneath our feet. So we now have a volcano. What's next in its life cycle? Just as living beings, volcanoes too have a life cycle, comprising 3 primary stages. The first stage is when the volcano is active. The volcano is alive and kicking, regularly spewing out magma and gases from its belly. This is the volcano in its most dramatic, fiery form. The next stage is when the volcano becomes dormant. It's like the volcano is taking a nap. It's not erupting, but it's not entirely quiet either. Magma is still moving beneath the surface and eruptions could occur. The final stage in a volcano's life is when it becomes extinct. It's like an old friend who has told all its stories and is now silent. The magma supply has stopped and there are no more eruptions. The life of a volcano, much like our own, is a cycle of activity, rest, and end. So, how do volcanoes form? Let's recap. Our journey starts deep beneath the Earth's crust, where tectonic plates are constantly shifting and grinding against each other. This intense movement and pressure heats up the rock, transforming it into a molten substance we call magma. This magma, lighter than the surrounding rocks, is compelled to rise. It pushes its way up through the Earth's crust, forming a path or a channel known as a conduit. When it finally breaks through the surface, we witness the birth of a volcano. From there, the volcano leads a fascinating life. It goes through stages of activity where it may erupt spewing lava and ash, to periods of dormancy where it seems to sleep. Eventually, it may reach a stage of extinction where no more eruptions occur. Next time you see a volcanic eruption on the news, remember the immense forces at work beneath our feet that make such a spectacle possible.